This is my digital guide in the area of maths and physics. The learning objectives of this guide is to learn about global trends in mobile technology and educational approaches in mathematics and physics. A global trend is access to mobile technology. Globally, most people own a cell phone. However, most people don't own a smartphone. Developed nations possess small smartphones because of affordability and resources available. Here are the top 10 smartphone penetration rates in the world. If you observe, they are all developed nations. The shift from desktop to mobile is a trend that has become more significant in the last few years. This can be observed for the global usage of the internet worldwide in this graph. We can also observe a similar trend in the US and Australia, where we eventually expect that mobile devices will take over desktop devices. In my own context, my disciplines are relevant everywhere in my world because almost everything around us is based upon the laws in these disciplines. Developed nations are developed as a society and use these disciplines to push humanity forward in advancement, while developing nations uses these disciplines in order to propel themselves forwards to become a part of the developed world. At the forefront of maths and physics in the developed world is a grasshopper rocket which has successfully completed vertical landing. This is Indira Gandhi Airport, and it shows how India, a developing nation, has used math and physics in engineering to create this as they strive to become a developed nation. These are my learning approaches. For situated learning, when learning in a context, it allows for a far greater and effective understanding. For information transmission, this is a general way of learning and how we come across information. And for social constructivism, when we learn in a group via collaboration, this allows for us to learn from others and not just from ourselves. Mathematica is a powerful computational tool that is useful in situated learning. We can study specific problems in maths and physics in a context with visual representations and simulations. We can simulate the ideal states of systems and obtain solutions of these systems. One such problem that we can simulate is that of the ideal pendulum, in that we just run this off the code in Mathematica, and there's no need to worry about external forces such as frictional forces or air resistance, and the equation that describes this pendulum is given here. Here I have modeled the ideal state of the pendulum. We can change the parameters and observe its behavior with respect to time, like so. From here we have clearly gained knowledge about the pendulum in a particular context, which is the ideal state. R is a programming tool used for computing statistics, and in my case I have mainly used it for performing data analysis. I have used principal components analysis on R. Rather than just studying the equations of this analysis, I can learn it in context on R and therefore learn it far more effectively. This is the code I have written for PCA for a particular dataset using the prcomp function. The output of that function gives me the standard deviation, the principal components labeled as the rotation, and I have also written a function that describes the principal components as a percentage of the variance, and I compute this and I find that 5 principal components make up 80% of the variance. And now this graph that had just come up is now a graph that describes the first principal component with respect to the second one, which has given me a scatter plot. LaTeX is a document preparation system written in code, rather than in a formatted form like we expect from Microsoft Word. It is primarily used for typesetting in academia. Here is some code that would be written into the console. The output of that code would be this. LaTeX assists in situated learning. This is because LaTeX is used to create a document about a specific context, such as an experiment. Digital text, digital reading material, or books on a screen. These are ebooks. The approach to learning in this case is information transmission. Knowledge is transmitted from the book to the student as they study. Physics and mathematics are notorious for having textbooks that are very thick and with large indexes. However, with ebooks, we can carry all of these on a single device, and instead of having to navigate through large indexes just to find a single topic, there's the option to use Ctrl F just to find what we're looking for. This makes ebooks in this field far more useful than their physical counterparts. The LMS discussion board is a social constructivist approach, and here we see peers collaborating with each other. In this example, we can see people interacting and contributing to the learning process, and as a result, they would have learnt something.